Hi, everyone. Thanks for joining the session, first of all. So I'm here to take it back to the basics, to go through basically, the technologies that myself, my colleagues, everybody uses in Immedius, and to talk about, the use cases, what kind of technologies are out there, how do they play a role in both RPA and AI. And for people who might not be familiar with the acronyms, RPA stands for Robotic Process Automation, and AI stands for Artificial Intelligence. So, just one slide about myself. I'm currently CTO of Immedius. I've been working in the technology industry for the last 18 years. Actually did a lot of consulting work with Deloitte in the past. So I had exposure to a lot of different technologies and different domains where technology were implemented. And ultimately, technology is to help people to do more, to make things easier. So that's the common thread for technology across the various domains. At the moment, I work with my fellow colleagues and my technology teams. Currently, there's probably about 150 different people in technology in Immedius, and we basically build platforms and technologies that supports the payroll um, space. So let's move to the next one. So the first part, I guess, to talk about, why we probably look to change the ways we work in payroll is because COVID has really amplified a lot of aspects of how we work. As you know, there is this term that people use called the Great Resignation, where a lot of people are resigning from their existing work or jobs or cutting down the amount of full-time employment that they're in. Personally, I would be familiar with a couple of close friends who have done that, either have looked to change of space where they work, or look at different industries that they might be able to do that. And I think one of the big reasons for that is because during COVID, when we work away from the office, um, we don't have the daily distraction of commuting to the office, meeting people for lunch, talking to people, physically, and that was a big part to the way we work, and it was almost like a good distraction to a working day, right? Whereas now we're very much isolated, sitting in front of a computer, doing things remotely, talking to people via a screen, etc. And that has really caused people to perhaps ask themselves questions like, is this what I'm going to be doing for the next 2 years, 3 years? What does my future look like in this new way of working? So I think a lot of people start asking them questions and they start to kind of go, maybe this isn't what I want to do for the next while. And a common theme by talking to my colleagues and friends, family, is that people are starting to really understand and question their value to what they do. Um, they're really starting to not want to do things that can be automated, things that are repetitive, things that are monotonous, right? They want to be able to basically do work that brings out the value in them and that have variations and are different and that cannot be done by a automated process. So it's even more important in this context that things that can be automated should be automated so that the employee, they have better work satisfaction. They don't have to every day log into the computer and start the day off with doing the same thing over and over again. So that's the first point there, which is better work for everyone. And automation also reduces error and mistakes that inherently, being human, we would introduce to process, especially ones that are constantly repetitive and we have to do the same thing over and over again. As you get tired, as you get stressed out, you introduce errors and mistakes. Automation also reduces the time required to do a piece of task because computers are typically quicker at doing the same thing over and over again than a human counterpart. Um, and by automating some processes, you would be able to reduce the manual cost of labor. Um, and looking at that positively, we probably should think by enabling, by having technology enablers, we're allowing people to do more in less time, so that they can focus on the more important things in their day-to-day work, as opposed to replacing humans. Um, Automation has AI has the benefit of helping you to pick apart the data, the data sets that you work with. I will touch this on a little bit later in one of the slides around how AI helps us to do things like what is supervised learning, what is unsupervised learning, what is correlation detection, etc. So I'll touch on that point a bit later. Real-time change and adaptability to business and market needs is very, very important. By leveraging the right key technologies in the payroll lifecycle, you can effectively automate processes, but you can also very effectively change how they operate very quickly. And later, I will talk about the technologies which enable us to do that. And lastly, typically in the payroll process, there's a lot of various different systems, and you're constantly jumping between them. You're constantly having to copy and paste, and you're constantly perhaps having two things side by side to compare and see if they're the same. So by using RPA, you can effectively aggregate a lot of different data sources, a lot of different user interfaces, a lot of processes into one place, so that you can have less screens to contend with. So yeah, I will move to the next slide. So before, I guess, maybe 10 years ago, if you go back, technology landscape was relatively different to modern. There was a lot less function-specific technologies and a lot more generic technologies which you cannot use for your specific purpose out of the box. You have to build it, and you have to have a lot of investment into it in order to get it to do exactly what you need. That has now changed, and it through the natural evolution of software, this is to be expected, because we had to build basically the foundation technologies in order to get to a stage now where technologies are more specific. They kind of start forking, but inherently they are based on very common technology platforms. But now we have flavors of different technologies, which helps in serving specific purposes. So I will talk about a couple of these technologies on this slide, which helps businesses to scale and automate. The first one is the microservices architecture and infrastructure. So what is microservices? It's if you think about one application, for example, if you think about your laptop is one computer. And at the moment, you typically do everything on that computer. You would watch YouTube, you would email, you would type Word documents, and you would basically run games or different applications on it. What a microservices architecture effectively do is, rather than having one computer that needs to be built to run everything, you break up the functions into smaller computers. So, for example, a PlayStation costs far less than a gaming computer. And the reason for that is the PlayStation is built to do one thing, which is to compute very intensive graphics, right? It's not so good at you telling you what to do or run Word documents. It actually can't out of the box. But that's an example of a compute platform which is designed to serve one purpose, and it does it very well. It does it cheaper and it does it faster than a general purpose laptop. So microservices, in a way, if you think about it, is many smaller computers, but each doing one thing very, very well. For example, one of these things could be managing your user database very, very well, whereas another instance of a microservice could be very good at computing payroll, formulas, algorithms very, very well. So microservices allows us to separate functional specifications into individual services, and together, collectively, they work into a process. And why is that important compared to the old world where we have monolithic services? Is that you don't need to build all the microservices you need upfront. You can actually start off by building one or two services just for your requirements. But later on, you're not bound by the previous services to build your subsequent features. So very quickly, you can see that you can start to scale. And also microservices, what it allows us to do is if we realize that that service managing the database is under load, we can scale just that service without affecting all the other functionalities, which is something, for example, your PC cannot do. If your PC is too slow, you kind of, at the moment, likely you have to go out and buy a new PC completely, right? So that's the benefit of microservices. Integration connectors and integration engines are technologies which allows a business to connect two separate systems together. And if you think about, what that really means is one system would store data in a particular way, or it might store, a user model in a very specific way. And in order for that user model to be accessible by a separate system, it might not be able to do that by just connecting to it, because that data model potentially could have, first name, and the second system could potentially have forename, for example. And they don't understand each other because they store data differently. So integration engines are key pieces of technology that allows you to map and transform data from one format to another so that systems can talk to each other. And in a very basic example, you can think of the fact that you have an Excel sheet and you can export it into CSV, right? So in a way, Excel gives you a little bit of a transform option for you to make a CSV file that other systems can read, that might not be able to read Excel, for example. So that's what integration connectors and integration engines do. Compute engines are a special type of software that allows you to build mathematic formulas into a system, right? Its speciality is actually the user interface. Its user interface is geared towards the management and the creation of compute rules. So if you think about Excel formulas and Excel algorithms, these systems can effectively allow you to upload an Excel sheet, including all its formulas, and these systems will actually understand these Excel files, understand the formulas, store them, and automatically generate APIs for other systems to use. I would just mention what API is, because perhaps not everybody knows what that is. API stands for Application Programming Interface. And basically what API is think of it as an endpoint from a piece of software that other software can talk to get information and to push information or ask for things, etc. When you actually go on to your Firefox browser and you hit Netflix, you are actually hitting an API, right? What happens is that your browser hits Netflix, and Netflix actually downloads an application onto your browser, and your browser then talks to the actual Netflix servers via the APIs. So that's how it works. So the compute engines, when they take in the Excel file and it creates the computation formulas, effectively you are able to expose the formulas and the algorithms to other systems without a developer at all, because it's auto-generated. And it allows you to actually test it and manage it in a very simple way that a business user can typically do without the intervention for technical or development people. The next system, the master data management system, is basically, if you think about data, typically exists in two states. One is called transactional data, and one is called referential data. So if you think about what is referential data is the data that a system needs to operate. So if you buy a new iPhone and you turn it on for the very first time, There's a lot of data on the iPhone, but none of them is your data yet, because it's so that the phone will turn on, so that when you go into settings, it knows what to display to you. All that is basically known as reference data. But as you start to use it, you're going to introduce transactional data, which is unique to yourself or unique to a person, for example, right? So there's two types of data there. A master data management systems allows the storage of reference data. Why is that important? It is because the following technology, the rules engine, needs reference data. It needs reference data such as what kind of currency does Spain use? What kind of currency does Bulgaria use? What kind of currency does China use, for example, right? And all that is known as master reference data, which need to be stored somewhere. And having a unified place to store all that data is really, really important, because you don't want that stored scattered all over the organization. And when someone changes in one place, you have to find the 10 other places that it uses it and to change it. So that's a master data management system. The rules engine is actually very, very cool. It's probably one of my favorite technologies here. The rules engine is, again, if you think about it, it's almost like an Excel file looking system that allows you to basically say, if I get, let's say, three inputs, the car, the model, and the engine, what is the insurance category that belongs to these three attributes? So in effect, you would create a table in Excel that basically becomes a rule. And the rule relies on three inputs and it has an output. Now that's a simplistic view of a rules engine. You can have nth dimension in a rules engine, and you can have more than just one return type. You can return complex data models. But in effect, it allows a user to basically say, if there is a holiday that's a bank holiday in the US on this particular day, then we know that we don't minus one of the annual leave days that this person have, right? So that's a simple rule, and it will be captured in the rules engine, and you would have these rules for many, many different countries, and applications can all access this and basically understand how to use it to do downstream processing. And lastly, indexing engines. Indexing engines are basically like Google. They basically go out to all the various systems you have in your ecosystem, and it pulls back all the data and it indexes it in a consistent manner so that you are able to retrieve data and you're able to view it, you're able to edit it, etc. So that's what an index engine is. In the interest of time, I will move on. So what is the difference between RPA and AI? Actually, lots of people asked me this question when I was putting together this deck and had my colleagues to proofread it. They actually asked me this question. RPA basically is when you automate something that's very well known and very well defined, right? You cannot automate a process that has unknown parts or has decision points that is not clearly mapped out. You just simply can't. It will fail if you try to do that, because you're not going to be able to go from one end to the other when it encounters issues along the way, right? So that's what RPA is. What is AI? AI is about identifying things you don't know from your data. For example, you have a big piece of demographic database. You have a big table, 1,000,000 rows, and you're kind of going, is there any pattern in this data? Is people grouped in any way? Is there correlation between pay, race, gender, what they do, etc.? You don't know these answers, but you have the data. So AI will be used to model these things, right? And like I mentioned earlier, supervised and unsupervised learning. So supervised learning is when you kind of have a hunch and you kind of go, something tells me people who in Ireland, technology developers earn more money than, let's say, doctors in Ireland. But is that true? I don't know, right? You use supervised learning to model that, and it will actually tell you. It will actually say, yes, 80% it's true based on this 1,000,000 data points you've captured. So that's supervised learning. It's to validate a assumption you have about the data. Unsupervised learning is exactly what I said earlier. You have all these people with different jobs, and you kind of go, what correlation is there in this data, right? And unsupervised learning would actually churn through the data, and it will actually go, well, did you know that the people who are software engineers in Ireland seems to earn more money than doctors in Ireland, hypothetically speaking. So that's basically what AI do. And RPA is used to automate known processes. AI is to help you to see things that you don't see. And when you see the things that AI would catch for you, you would kind of go, okay, I need to do something here, right? Maybe this person is way underpaid compared to 90 other person in the same country, in the same kind of work. So that's the difference between RPA and AI. So the power of RPA. I'll quickly just touch on all these things. We have validators. We have smart validators, and what it does is it validates data input, right? So instead of a human going and see, is this Excel sheet complete? Is it accurate? Is it in a good form? We have a system that does that, and it would actually run it through a rules engine. It would return against everyone, red, amber, green. Amber means, yeah, you need to fix something. Red means this field is completely bonkers. We don't, the system cannot process it, right? For example, you have letters in a numeric field. Smart connectors is basically out of the box connectors that a lot of systems actually have now to connect various technologies together, like HCM, CRM, the different things, right? And smart connectors basically means you don't need to tell me how to map data. I'll do it for you. I know what it is. You just tell me where the source is and where the destination is. I will do all the mapping for you. So that's smart connectors. Transformers, works along with the connectors. They connect, they understand the data, and they know how to transform data. Yes, that's correct. And global payroll reference data is, when you, like I mentioned earlier, when you consolidate all your global payroll reference data in one place, you kind of can break it down into two different buckets, right? One is the common bucket. So everywhere in every country, we kind of need to know what the gross pay is, what the tax is. That's common. And then in other places, what you have is country-specific information, right? CSI, and that drives unique country legislations and requirement. So having all that in one place is really beneficial because it encourages reuse, and it also allows people to manage it centrally. And it also helps people to kind of go, yeah, I think I've seen this before, right, in a different country. So you can kind of go off and you kind of look at it, and it helps you to create new rules, basically. The compute engines, like I mentioned earlier, it takes the rules, takes the reference data, it takes your transactional data, all the numbers, all the pay elements from your employees, and it basically is able to compute in a consistent manner all the algorithms, etc. So you don't have to manually do it, right? And a smart user interface is actually very, very close to my heart, because payroll is, relatively speaking, data heavy. The user interfaces are very, very big. It's almost like looking at Excel sheets a lot of times. It's really, really important for systems to be able to color code things. Like I said, like the RAG status, if there's an error with a particular field data, that it's able to color code. So very quickly, you're not wasting time manually trying to seek through the data and look for things that doesn't make sense. You just basically focus your time on the fields that needs user intervention. So that's a smart interface. And smart analytics is very much that, being able to gain insight, what we called dumb insight, basically reports, how many people joined, how many people left, is there any correlation between the pay to the people that has left, etc. So really analytics based on known data, existing data. And then the power of AI. So AI actually touches on all these points. And myself and my team, we actually, try to make things even more smarter by leveraging AI. And just to give you some, examples of what that really means, um, connectors and transformers, we spend a lot of time developing and configuring, right? And so instead of kind of doing them manually, one by one, we would often go, well, what if I can make it a bit more clever, right? Maybe I will build a system that basically has all possible keys for first name, forename, all the keys for surname, and let my system be a bit smarter, a bit more clever, in kind of correlate what the input is to the output. Um, so I think the key though of AI in what I described in that process is around the analytics. For us, definitely the analytics has a standout because we want to build analytic systems that doesn't just report on known existing stuff. It's things about detection of payroll anomalies, right? Kind of going, wait a second, this guy's been paid €100 per month for the last 10 years. Why is today different, right? Has something changed in the process or in the inputs to warrant this change? And if the answer is no, then we know there's a problem with this payroll and people underpaid, for example, right? And so it's that kind of things um, that we want the AI to be able to drive. It's to detect patterns that break out of the norm for a particular payroll run and cycle. So if you combine the two, you get a very, very smart solution. A solution that can, by all intent and purpose, potentially do the whole run without human intervention. Um, but I would probably just chip in here and kind of say, ultimately, payroll from a technologist perspective, like myself, is inherently getting data input into something and do some process on it. And like any good data scientist will probably tell you, the challenge is always the quality of the data, right? Um, 70 to 80% of the effort for my team, for example, or even just most of the data scientists who work with large sets of data is spent on making the data consistent, accurate, and clean, right? It's not polluted by unneeded data. Um, so from that perspective, the system can be as smart and as intelligent as it can, but ultimately, if the data going into it is of poor form or malformed, then the system cannot cope. The effectiveness will rapidly drop off a cliff. Um, so yeah, so basically, that's the key to all these RPA and AI processes.